Alright guys, this is the first of several videos on Chapter 4, which is entitled Designing Studies. So Chapter 4 is all about designing studies, and we're going to learn a lot of different things that go involved into doing this. The first thing that we need to understand is what is a statistical study, because we're going to work a lot with this chapter, and you're going to actually create your own. So in a study, information is collected and analyzed to better understand a variable of interest, or the relationship between two variables. Any study starts off with a research question. So the basics of a statistical study is, hey, I want to learn something. I want to learn something about a particular variable, or I want to learn about the relationship between two variables. So there's a couple different types of research questions. The first off, if the answer you get or the value you're looking for is a percentage, then we call this a proportion. So if I am interested in what percent of teenagers smoke marijuana, that would be a research question. I want to find out a particular information about a group of people. What percent of adults are overweight? That's another proportion. What percent of grizzly bears are over 500 pounds? What percent of coral reef are infected with the disease Flangiophatilia? Again, these are all questions that these are all variables of interest, things that I want to know about. And to do it, I have to ask a question. But if the answer is going to be a percentage, that is what we call a proportion. We could also have an answer that is a mean, for example, a number, right? So what is the mean commute time to work for adults in Ohio? So what is the average amount of time it takes somebody in Ohio to drive to work? The answer is a mean, and I want to investigate that question. I'm interested in studying that question, and again, the answer is coming back in form of a mean. Another example would be, what is the mean weight of a fish in Lake Erie? What is the average weight of a golden retriever puppy? What is the mean amount of money spent by teenagers on a trip to the mall? Again, these are all questions that the answer is going to be an average or a mean. And the other type of research question is when we're looking at the relationship between two variables. Now, I'm not talking about asking two variables. I'm talking about looking at the relationship between two variables. For example, does watching violent TV shows lead to lower grades in school for elementary students? So I want to see, does watching TV, so does doing that, watching violent TV, lead to lower grades in school? So those are two things I want to look at, the relationship between them. Does using magnets placed at the source of pain help lower the pain? So if you have pain in your knee, if I put magnets on my knee, will the presence of those magnets help me get lower pain? So again, that's two things, magnets and then the pain level. Does taking a new blood pressure pill actually lower blood pressure? So if there's a new pill that's supposed to help me lower blood pressure, will it actually work? So I'm looking at the variable of, do I take the pill, yes or no, and what is the effect of the pill on my blood pressure. Another one is, does the new fuel additive help increase the gas mileage of a car? So there's a new fuel additive. It's like a little bottle. You dump it into your gas tank, and it helps you get better gas mileage. Again, does the presence of that, yes or no, actually change the amount of gas mileage in your car? All right, to answer any of these questions, we must first begin by identifying our population of interest. The population is the entire group of individuals that we want information about. We call the population size N. Now, to be quite honest, we're never actually going to know the population size because it's so massive in a lot of things, but sometimes you could know it. But we do a capital N to represent the size of a population. So the second thing we have to do is we have to say exactly what it is we want to measure. So be extremely specific what it is you're measuring when you start collecting your data. So again, that's where that research question comes in. Now we have to actually go ahead and collect our data. So if your population is small enough, you can actually perform what's called a census. That is a key word here, census. A census is where you measure every single person in your population. Now that would be great if you can, right? If your population is fairly small, like if you work at a small business and you only have 13 employees, well then yeah, you could do a census. You can ask every one of your employees a specific question. But in most cases, populations are fairly large, so we choose to select a sample to survey. A sample is another important term here. A sample is a subset of individuals in the population from which we actually collect the data. The size of a sample is lowercase n. So we have our population, this big group of people, and we want to take out a small subset called a sample. And that is the simple idea here of collecting data from a sample. All right, so let's talk about how you could sample badly, right? Sometimes I usually do this at the end, but I'm going to actually start with this time. I'm going to tell you all the bad stuff that can happen, then we'll talk about the good stuff. So there are three really, really bad ways to sample. The first is what's called a convenience sample. A convenience sample is when you choose to collect a sample of data from simply because they're easy to reach. So the sample that I choose to collect from is just easy for me to get to. Like if I have a population of Twinsburg High School students and I choose just to select the students in my first block class, well, they weren't really chosen randomly, and I just chose them because I didn't have to do any work. That's a bad way of doing a sample. Another bad sample is called a voluntary sample. This consists of people who choose themselves by responding to a general invitation. So basically, if your sample is made up of volunteers, that is very, very bad. Oftentimes, the people that volunteer to give information to you are people that have strong opinions or strong feelings one way or the other, and you don't really want to use volunteers in your sample. The third method is just what we call kind of a general bias sample. This is kind of basically general. This is saying, listen, if anything you do in your sample consistently over or underestimates the true value that you want to know about, then it's biased, right? Very simple example. If somewhere out there the true average weight of an adult grizzly bear is 502 pounds, and for some reason I only measure young bear cubs, like little babies or something. And obviously that's biased because I'm only looking at young cubs, and young cubs are going to way underestimate the true average sample of a grizzly bear if I only look at younger ones. So again, I want to get a good mix of all different ages to get a really good feel of what the average size is. So anything you do that consistently over or underestimates your truth is obviously going to be biased. Okay, what else can go wrong? Well, another thing that can go wrong is what we call undercoverage. Undercoverage is when your sampling method specifically allows for some members of the population to not be chosen. A very, very commonly used example of this is if you survey people by phone number and you use a phone book to get their phone numbers. Well, the problem is a lot of people nowadays don't have phone numbers in the phone book because most of us have cell phones and we allow that cell phone to be our only phone number. We don't have, a landline. So that means if you weren't in the phone book because you have a cell phone number, you never had a chance to be chosen. If their method was picking numbers out of a phone book, you would never get a chance to be chosen, and that is not very fair. Another thing to worry about is called non-response bias. This occurs when individuals selected for the sample can't be contacted or refuse to participate. Basically, if Miguel is chosen to be a part of your sample, you need to contact Miguel and you need to get information from him. You cannot allow a person that is selected to just refuse to participate. Because the issue here is oftentimes the people who choose not to respond differ from those that do respond in a very meaningful way that is related to your response variable that you want to know about, right? Maybe Miguel is not choosing to respond because he's embarrassed to give me his value. Well, I can't just allow that to not be given to me. You know what I'm saying? I have to get his response. Ways to fix non-response bias are just to call Miguel, go to his house, visit him. You can even use some type of incentive, and I'm not saying bribe Miguel, but do something to convince him that he does need to give his response to you because, again, he was selected. All right, the third thing that we're going to talk about in terms of what can go wrong is called response bias. First off, I put in the bottom corner here, note that this is not the opposite of non-response bias. It's actually something completely else, so don't confuse them too. Now, response bias is anything that may cause a selected individual to not give a truthful response. So, again, response bias. The response from a selected individual is not true. This could happen because the wording of the question is biased or confusing, and means they might not give the best answer because they don't understand the question or because the question is worded in a way that tries to elicit a certain response. Sometimes it can be even who is asking the question. For example, when I go to the dentist and the dentist says to me, hey, have you been flossing your teeth every day? Of course I say yes. Again, I lied simply because it was the dentist who asked me. Well, of course I don't floss my teeth every day. Social desirability. If you ask people a question in a setting where there's other friends or peers around them, they typically might give a wrong answer simply because they don't want to look bad. For example, if I ask in the middle of class, hey, who here smokes marijuana? And let's just say that Sally does, she might lie to me because she's looking around the room and she doesn't want her friends or peers to know that she does. So again, that would be response bias. Another form of response bias could be a broken measuring device. Let's just say I'm weighing those bears and the measuring the measuring the scale that I'm having the bear stand on is broken and it's giving me wrong answers, well, it's not the bear's fault, but I am getting a wrong, untruthful response because of something that I was doing. So any of those are examples of response bias. Okay, so now let's talk about good ways to select a sample. Okay, because obviously this is what's important. I want to know how to select a sample a good way. There are 4 good ways to select a sample, and these are in no particular order. I did separate this 4th one here because it's not necessarily everyone says that systematic is good, but it is a good way. It can be good, and I'll talk more about it when I get to systematic. But the top 3 are simple, random sample, stratified, and cluster. So, in order for me to talk about these 3 things, I actually want to do an example. And as we go through these different sampling techniques, I'll use this example to help explain them. So the population is students at Twinsburg High School. So just so you know, there's roughly 1,300 students at Twinsburg High School, somewhere around there. And that would be the capital and the population size. And I want to know what % of students eat breakfast every morning. So I'm going to ask the question, do you eat breakfast every morning? And I'm going to get yes or no, and then I could take the yeses, divide it by my total, and I can get a percentage, right? Okay. Now my sample size I'm looking at doing is 40 students. I'm looking at selecting 40 students. Okay. So let's talk about how to do what's called a simple random sample. We sometimes call this an SRS for short. Now, a simple random sample, by definition, is that every possible group of size n must have an equal chance to be selected. So if I'm going to select 40 students, every possible group of 40 students must have a chance. Now, even if that means that I change one person, if I change Vince with Trinity, if I make a switch right there, that would be a different group. So every possible group of 40 different students must have a chance to be selected. Okay? Note, a lot of kids think that a simple random sample means that every person has an equal chance. No, by definition, it's not about every person having an equal chance. It's about every group of size 40 having to have a chance. So imagine a group of all 40 boys somehow randomly gets selected. That group under an SRS must have a chance. Imagine a group of all 40 students selected just so happen to be in AP Stats. That group of 40 students must have a chance to be selected. Now, albeit those groups would probably be unlikely to happen by random, but they need to have a chance. Another example could be all 40 kids selected just end up being freshmen. That would be very weird to randomly select students and all 40 of them are freshmen, but that group must have a chance to be selected. So the best way to actually perform a simple random sample would be to give everybody a unique number and then select n numbers at random. So let's just say there's 1,300 kids at Twinsburg High School. Everybody's going to get a number 1 through 1,300, and then I'm going to randomly select 40 of them. Now, how do you actually randomly select numbers? Well, there are 2 ways to truly randomly pick numbers. And some kids say, well, can't I just put everybody's name in a hat and pick them out of a hat? We'll talk in class that that's really not the best way of doing it. We need it to be truly, truly random. And there are 2 ways to do this. First off, if you use your calculator. Our calculator is kind of known as what we call a random number generator. It can randomly generate numbers for you. So if you hit the math button on your calculator, and then slide over to the PRB at the top, and then go down to random integer. What you could do is you could put in random integer 1, 1,300, and this is assuming I have exactly 1,300 kids in my school. So if it was 1,326, then obviously I put 1,326 there. And after you do this, what happens is hit enter, and the calculator will randomly pick a number for you. And then you can keep hitting enter, 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 and keep getting random numbers. And again, that will allow you to randomly pick students. Or you could use something called a random number table. A random number table is literally exactly that. It's a completely random table of numbers. Here's an example of one. And the idea is that everybody has a number, again 1 through 1,300, and that means I need to use 4 digits, okay? Because if the biggest digit has 4 numbers, then I need to use 4 digits, which means this would actually be 0, 0, 0, 1, 0, 0, 0, 2, all the way through 1, 3, 0, 0. So I would first say, okay, let's go to this random number table and let's look at 4 digits, okay? So 8094. Well, That's outside of my range. So I would have to say, ignore that number. Nobody has that number. And then I would go 2525. Okay, well, nobody has that number. And you would keep going until you actually generate your 40 numbers. Now, I agree, using the random number table could take a while, especially when you got to think about ignoring numbers that are outside of your range. But that would be how you do it. And that's the point of a random number table, is it's completely random. Now, when you do any of this, you do have to go through a couple steps. So it's kind of silly to actually do this, but it is important that you follow these steps. So to select a random sample, you must give every individual unique number, 1 through however big your population is. Then you're going to use a random number generator or a random number table to select the numbers. You do need to make sure that you ignore repeats, because if person 1326 is picked twice, well, they can't be picked twice. You got to make sure you say ignore repeats. And also, you have to make sure you ignore numbers outside of your range. As we just saw using a random number table, oftentimes numbers come up that nobody has. So you have to make sure you tell me to ignore those numbers. And then the final thing is, when do you stop? Make sure you tell me I'm going to stop once 40 unique different numbers have been selected. So that is the process to how to do a simple random sample. Okay, up next is what we call stratify sample. Now let's try to explain this. All right. When you do a stratified sample, the first thing you do is you break the population into groups based on a common, similar characteristic that matters in context. When I say it matters in context, I mean something that actually has to do with the question. So this is what we call homogeneous groups. So you create groups of students that have something in common, okay? So I'm going to talk about this a couple different ways. But the second thing you do is, once you break these students down into groups, you select a random students from each of the groups. And notice I capitalized and I highlighted and underlined that word each, because that's the idea of a stratifies. You take some students from each group. This guarantees a representation from all the different groups, which is really important. So, for example, I got my students at Twinsburg High School. I can break them down into freshmen, sophomores, juniors, and seniors. Then I could take 10 randomly from each grade level. That would be stratify. So I separate the students by grade level, and then I took 10 from each grade level. This would guarantee me I have a nice mix of freshmen, sophomores, juniors, and seniors. See, the issue is, if I think about a simple random sample, a group of 10 freshmen, 10 sophomores, 10 juniors, and 10 seniors never had a chance to be picked, because there is no way that that could be guaranteed to be happening here. And I guess I probably didn't say that very clearly. So the idea of a simple random sample is that every group must have a chance to be selected, even a group of all 40 students being freshmen. Well, if I specifically take freshmen, sophomores, juniors, seniors, that wouldn't technically be a simple random sample, because that group didn't have a chance to be selected. Okay? And I really want this to be clear, so I'm kind of talking about it a lot. But the idea is that in a stratified sample, there is no way I could get all 40 freshmen, because the way I designed this was to have 10 of each grade. So all 40 freshmen, which in a simple random sample has a chance, albeit it might be unlikely, it still has a chance. In a stratified, that group of all 40 freshmen has no chance of being selected. All right, now, you could do it a couple different ways. Another way you could do it is by gender. You could just do a group of males, group of females, take 20 from each group. Okay? That's another way to stratify. How else can you stratify? We could do maybe ethnicity. So you got African Americans, white Caucasians, you got Indian and Pacific Islander, you got Native American maybe you got Hispanic, and then you don't have to take the same number from each group, but you just have to take some from each group. So if there's more Caucasian kids in the school, maybe we take 20 of those, 10 African American, 2 Hispanic, 2 Indian, and I forget what the other group I had left behind. Maybe Asian or something. You could take a couple from there, whatever is needed. You don't have to take the same amount from each. You just have to take some from each to get a nice representation. So hopefully stratified makes sense. All right, up next is cluster sample. Now, cluster sample is a little bit different. It's going to sound a lot like stratified, so pay close attention here. we're first going to break the population into groups that are very diverse and mixed up within. So again, we're going to break up into groups, but the groups within each group, it's already very, very mixed up. So in each group, we might have freshmen, sophomores, juniors, seniors, different ethnicities, different backgrounds, different ages, different socioeconomic. They're very mixed up. So you create these groups that are heterogeneous, meaning very mixed within. Then, second, we randomly select one or more of the groups to be taken as the sample. So instead of taking a couple students from each group, we just randomly select one of the groups to become our entire sample. So let's just say that we label them 1, 2, 3, 4, 5, 6, and then we randomly select number 2 to be our sample. The idea here is that everybody in this selected group is now part of my sample, and that group was already nice and mixed up and diverse to begin with. So I now have a very good group. Okay, so the difference between cluster and stratify, if we go back to stratify real quick, we selected groups and then we took a couple people from each group. That's the point. We took some kids from each group. Cluster is you break into groups and then you take one or maybe two of the groups to be your entire sample. So hopefully I'm being very clear on that. So the key is the groups are already mixed up so that they represent the population, and then only a select few of the groups are taken. All right, so systematic is that last one I talked about. Systematic's a little bit different, but it's actually really easy to recognize. Probably the easiest one to recognize in a multiple choice question or something like that. First, choose a random starting point amongst your population, and then select every kth person until you have the sample size you've desired. So maybe I'm going to select every 10th person. So the idea is I'm going to stand outside Twinsburg High School in the morning, and every 10th kid that walks in the door, I'm going to ask to be part of my sample. Or maybe I'm going to go to the office and get a list of every student. I'm going to pick a random starting point, and then from that starting point, every 10th kid becomes part of my sample. So that's how you do a systematic, but it still is random because where you're starting needs to be random. All right, so let's look at an example here, and I want to talk about the 4 of these different sampling techniques with this example. So imagine a warehouse where we have 200 boxes, each containing 500 batteries. So we got 200 boxes. So 1, 2, 3, 4, 5, 6, ... I'm certainly not going to draw all 200 boxes here. Okay, but the idea is that each box contains 500 batteries, and we want to select a random sample of 100 batteries. We want to select 1,000 batteries. My fault. So how could we do this with a simple random sample? Well, with a simple random sample, we would have to take every battery out. So we would have to take every battery. So that's 200 boxes times 500. That is a grand total of 100,000 batteries. And we would have to give every battery a number, 1 through 100,000. And then I'd have to randomly select 1,000 of those batteries to be selected. I would ignore repeats. I would ignore numbers outside my range. I would stop once I have 1,000 total batteries to be in my sample. That sounds kind of time consuming, but that would be a simple random sample. All right, stratified sample would be, well, wait a minute, this is actually easy. I already have boxes made up of groups of batteries. In each box, there should be 500 batteries. They should all be fairly similar, right? They're all in box 1 or box 2 or box 3 or box 4, all the way to box 500. And then what I would do is I would select some batteries from each box. Okay, that would make it stratified. So to go around to every box and take a couple batteries out of each box. Now there's 1,000 batteries that I want, and there's 200 boxes. So if I would select 5 batteries randomly from each box, now that becomes stratified. Cluster sample would be, okay, I got 200 boxes. Well, I put a 500 here. That should have been 200. Sorry. I got 200 boxes of batteries, and I'm going to randomly select 2 of them to become my sample. Maybe box 2 and box 49 gets picked. So now remember, there's 500 in each box. There's my 1,000 batteries. But the idea was I didn't take a couple from each. That was stratified. I just picked 2 of the boxes to become my entire sample. That's cluster. Systematic would be if I go ahead and say, okay, I'm going to select every 100th battery. So I'm just going to start counting all the batteries, and every 100th battery that I select becomes a part of my sample. So, simple random and stratify sounds like it would take too long. Stratify even sounds like it might take a while because I got to take some from every of the 200 boxes. So to be honest, cluster might be the best option here because all I got to do is randomly select 2 boxes and boom, that becomes my sample. All right, here's another example. We have an auditorium, and the entire school is sitting in the auditorium. And the front rows are the seniors, the next rows beyond that are juniors, then sophomores, then freshmen. If I wanted to do a simple random sample, every single student would have to get a unique number, and then I'd have to select, let's just say I want to pick 20 kids, I'd have to select 20 numbers. That's simple random. Everybody must get a number. All right, if I want to do a stratified, well, again, they're already broken down into grade. So I would go to the seniors and take 5 seniors. I would go to the juniors, randomly take 5 juniors, take 5 from the sophomore class, take 5 from the freshman class, 5 from each class. Boom, that's stratify. I broke them down into grade level, took a couple from each grade level. If I wanted to do a cluster, now think of it like this. I want a sample that's a good mix of all grade levels, correct? So then I'm going to create columns. So here's a column. Maybe that would be column 1. So that would be seats 1, 2, 3 going that way. Here would be another column, another column, another column, dot, 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 dot. I'm not going to continue it on. You get the idea. And then what I would do is, let's just say I have 20 columns. I could randomly select one of the columns to become my entire sample. And why would that be good? Because each column has a mix of seniors, juniors, sophomores, freshmen. So again, each column has a chance to be picked, but I'm only going to pick one, or maybe I need to pick 2 columns to become my entire sample. That's instead of taking a couple from each. So hopefully that makes sense. Okay, now lastly I want to just talk about this idea of inference. Okay, the purpose of a sample is to give us information about a larger population. Guys, make sure that really makes sense. The whole point of taking a sample is I don't have time to get to the population, so I want to use what I learned from that sample to talk about the population. The process of drawing conclusions about a population on the basis of a sample is called inference. However, it is unlikely that the results from one sample are exactly the same as other samples or the entire population. You have to have the understanding that just because our sample comes back that the average grizzly bear weighs 562 pounds, it doesn't mean that that is exactly what's true for other samples of grizzly bears or even the population. So it's important that we understand this idea. It's called sampling error or sampling variability. This is the idea that 2 samples are going to naturally vary from one another, and they're also going to naturally vary from the population. Nothing you can do to get rid of this. This is not an error like you did something wrong. It's just an idea that there's a natural occurrence that not all samples are going to be the same. And our job as statisticians is to analyze our sample and see how close is it to that true value. The only thing I can say is that we cannot get rid of sampling error or sampling variability. It's the same, 2 different terms for the same thing. But if we ask bigger samples, we will get a better answer, if you think of it that way, right? If I weigh only 5 grizzly bears, I might not really get a very accurate answer. I'm going to have a lot of sampling error there. 5 grizzly bears could vary a lot from another sample of 5. But if I look at 100 grizzly bears, I'm going to be much more accurate when comparing other samples of 100. So you have to understand the idea is that when we take a sample, no one says it's guaranteed to be true. Heck, if I take a sample of 40 students from Twinsburg and Melissa takes a sample from 40 students, we might not get the same answers. It doesn't mean one of us did something wrong. It's just called sampling error. Okay? It's not an error in terms of you did something wrong. All right. Last up is let's now talk about how to investigate the relationship between 2 variables. And note that I'm not talking about asking 2 questions. I'm talking about how does one variable affect another variable. And when I say impact, I can mean a relationship or association. So we're talking about an explanatory and a response variable. We might even want to someday go as far as talking about can X cause Y. There's 2 ways to collect data to learn about how one variable affects another. One is called an observational study, where we simply observe and watch how those 2 variables impact each other. The second is what we call an experiment. An experiment is where we have full control over the explanatory variable, and we decide who gets the explanatory variable and how much, and we look at a response. So we'll talk a lot more about those 2 things. I know I'm kind of throwing them in there at the end here, but we'll talk a lot more about these 2 things in actually the second section of this chapter. All right, guys, that's it. Talk more about it in class and do some examples.